we're on time? Oh, awesome. Welcome, everybody. Nice to see you all here today. I'm very honored to be speaking here at RSA this fine Monday afternoon. So let's get started. First, a disclaimer. The stuff that I say here are my personal opinions and my experiences. They are not true for all security organizations or people who build security products. And what am I here to talk about today? I feel like this microphone is maybe on, but so can that not be on and I just use this one? Cool. So what am I here to talk about today? Well, I'm here to talk a little bit about an evolution of our security strategy at Netflix. I'm going to share some learnings from years of developer-centric security efforts, and so that you might learn from some of our successes and mostly from some of our mistakes. And so that you can maybe put down some gravel on your own. And who am I? For those of you who don't know me yet, I'm Westelius. I am the Director of Security Engineering at Netflix. Prior to this, I led security products at Cruise, and before that, I've held a variety of security and engineering director positions across roles in companies operating across Europe, Australia, and here in the US. We do a lot of security stuff in my org. You see a lot of security words here. We are hiring for many of them, and so if you are interested in looking at any of those roles, feel free to find me later and we can talk about it. I am originally from Stockholm, Sweden. Pictured here is the eastern entryway to the city, my entryway to the city. This is the path that I would take into my job every day. I worked in Stockholm and where I would go in to see my friends from the suburb in which I grew up. Pictured here is, by Swedish standards, a fairly complex highway intersection, river locks, and a train complex that connects the southernmost island with the center part of the city. The sluice, or in Swedish, Slussen, was originally designed to address the effects of the arrivals of the automobile to Stockholm in the 1920s. This had led to huge amounts of traffic congestions, and it was explained as like the most miserable place to be at the time. They had not scaled particularly well. The construction was completed in the 1930s, and it became a sort of symbol of the modern era. It was the arrival of the automobile, it was to support it, it was really the modern sort of traffic engineering. And over several years, it became sort of like a cultural phenomenon, a representation of Stockholm for whatever reason. Many people in Sweden had strong opinions about the construct. And by the 1970s, 40 years after its construction, it had stopped being particularly useful to its users because the shape and size of traffic had changed drastically in those 40 years. And by the 90s, when it was still standing, it was quite literally falling apart. I remember passing through here and parts of the ceiling would just like accidentally land on the ground near you. But bureaucracy haunted the replan of designing something new for this because it was like as every Stockholm citizen had an opinion about the replan. Everybody had to, provide their own design or change the architecture. And the cycle also repeated itself every time the city found itself in a new government. In 2011, after years and years of debate and several more competitions for designs and re-architecting, the plans for the new sluice was approved and construction began in 2014. It's expected to go on through 2025, almost 100 years since the original sluice design was approved and way too long after it stopped being particularly useful to its users. The new sluice will be much better suited to serve the modern Stockholm and its people. This is a pretty extreme example of failure to change due to an almost pious relationship with what was and an ill-informed desire to preserve it. As security teams, I think we need to be continuously evolving and rethink the way we think about our strategies and how we scale to our modern ecosystem. And so today, I'm going to talk a little bit about how we change our perspective on security strategy over the last few years. This was a brief agenda. I will talk to you a little bit about the methodology that we based our strategy around. I'll talk a little bit about our successes and some of our failures. And then I'll share a list of recommendations that you might be able to apply in your own teams. So what is the paved road? We use this concept quite frequently at Netflix. Let's talk about that for a minute. this was conceptually, this is about making life easier for developers. So the paved road or paved path is by no means a security term. It was a concept that was developed by our central productivity engineering partners at Netflix several years ago. It was popularized by Netflix and has been used almost interchangeably with easy-to-use developer-centric tooling. Conceptually, the idea should be relatively non-controversial. Make developers' lives easier by offering tools, services, and workflows that make choosing the fully supported method the right and most easiest thing. Maximize developer efficiency. And from a security perspective, this means a set of methods that either fully supports secure by defaults or significantly eases the implementation of a security control. Simply put, the security paved road should ensure that the easiest path to production is also the most secure. This allows engineering teams to develop, build, and deploy their apps in a continuous manner with little or no input from the security team. Great. And here's a couple of examples of developer-centric paved path tooling, not particularly for security. So at Netflix, we have something we call managed delivery. It's a simplified delivery and infrastructure management experience for application owners that lets application owners focus more on their products instead of deployment. It's a continuous delivery system built on top of Spinnaker that allows developers to specify their delivery flows and infrastructure as code, and it continually monitors applications to automate the corresponding deployments and infrastructure management. So automated asynchronous patching, for example. Another example is a Evergreen by Segment, which is a React component and UI framework built to make building products on the web super easy, and they ship with really smart defaults out of the box. And if we apply a security lens to that, managed delivery not only comes with a lot of really great built-in security features like management of security groups, access management, and such, but it also automates patching, which is really useful for incident response. And in the example of Evergreen, they've actually removed most of the insecure defaults that come with React and making it really hard for people to accidentally introduce vulnerabilities in their code. And so is this not just shifting left or securing the SDLC or DevSecOps? Yes, sort of. And aren't all of these just security buzzwords? Yes, it's absolute security buzzwords. But this is RSA, so I hope you brought your bingo card. And for now, let's just use this as a framework for articulating developer-centric security engineering investments intended to enable autonomy and security posture ownership by engineering teams. And so back to the paved road. Here are some of the intended outcomes that we aimed for when we went down this path. And so first of all, we want scale. We want to spend less time in labor-intensive security reviews and assessments. We want to do less manual, repetitive work. We want to simplify security, make understanding security concepts easy and more accessible to developers. We want to encourage developer autonomy. Engineers should own their own security and risk posture. We want to enable secure by defaults, reduce or entirely eliminate entire classes of vulnerabilities through secure defaults and opt-out standards. And we want privacy by design. So we want adherence to regulatory and compliance standards from the get-go. And going down this path means taking some bets, right? We're going to do less manual reviews. This means we're going to do less hands-on security. And so we're hoping that we will scale security by providing the easy choice in the right context. By offering guidance to developers, they will seek us out and not see us as a blocker. I'm sure as security professionals, you've met engineering teams who are worried to approach you because you're the ones who say no. We're trying very actively not to be that. We hope that we will get increased adoption of security controls by making them easily available. We believe that developers should own their own security posture and that will be fine. And we will spend less time in manual reviews without negatively impacting our security posture by focusing on big systematic wins. So sometimes you gotta let those fires burn and focus on the big wins where you can make high leverage and impact. And we will achieve those big wins by stacking our bets on central platform partners initiatives. So when we have a big infrastructure initiative that happens in central engineering, we want to tag team with them and making sure that we're building security controls where our developers are. And a little bit of a caveat here too, different organizations will have very different needs. And so at Netflix, much of our investments are driven by more than 7,000 internally developed applications, many of which pose different challenges or be more or less risky. And so my recommendations here today are based on my perspective here, but should be generally applicable to any size organization or team. And so when we first got started, like we started out on this paved path road, we began by examining the software development lifecycle and thought about which solutions could provide more easily and with a lot more impact. At the time, our business model was a lot more simple. We had mainly the main sort of Netflix application that you know today that streams video. And so we focused a lot in that ecosystem in particular. And so we added universal CSRF protection for applications in the consumer product path. We did this by introducing protection controls through our API gateways. We leveraged our paved path node framework to eliminate XSS in that ecosystem, so we made that unavailable. And we made SSO and authentication products broadly available to all application owners so they could easily implement strong authentication everywhere. And we also invested in sidecars and proxies to provide a nice baseline of security controls, such as identity and access, layer 7 firewall, rate limiting, DUS protection, and logging and observability tooling. But as we progressed and we evolved, we worked not only to provide and enable the right security features in sidecars and in frameworks and runtimes, but also provide products that would achieve our goal of enabling use cases while enabling us to scale better. We generally moved out of runtimes and languages to sidecars and proxies and focused on finding infrastructure-wide initiatives that offer broad security and privacy benefit. So this is not an argument against or for sort of proxies and sidecars versus client and language-based security. They have their own pros and cons. But for us, this spoke to a need to scale and also something that supported us in a very polyglot environment. Sidecars and proxies are very effective in places where you don't have a lot of standards or consistency. And a few high leverage examples that we've implemented. I will talk a little bit more about this later, but we have API proxy, or WALI, which is for internet-facing applications that need a bunch of standardized security features. It adds authentication, WAF, DDoS prevention, standard security headers, and access policies by default. We've done a similar approach for our data stores. We have something called Data Gateway that does data protection and offers auth and auth-C for data stores by default. And we are investing in service mesh. This is still an evolving picture at Netflix. Implementing service mesh on a really large ecosystem is complicated. For those who have not tried it, I do recommend, but it is hard to get right. But that would offer mutual TLS authentication and authorization by default for all services on mesh. And so here it is, illustrated the paved road. As you can see in this photo, there is a finely paved road for those who just like to get where they're going. Imagine that this is your fully supported tech stack. You can simply bootstrap your application. You get all the secure by default. We, as a security organization, do not need to engage with this application owner. They get everything baked in. Everything happens out of the box. But their use case might be quite simple. But there is also a couple of folks who have taken this path right next to the road. It is pretty well used, but it's requiring a little bit of extra skill and coordination to go down. So, maybe this is a more bespoke solution. Maybe we're trying out something new. Maybe we're experimenting with something, and we haven't really decided what type of security standards we want to support broadly for this use case. This would need a little bit more hands-on help for our security team, but not a lot. And in this fully open environment, if you look closely, you can see that somebody took a left-hand turn and averted the road altogether. And this is my friend Donut. Honestly, the first opportunity I have to write something for work that doesn't need to be dependent on by other services or code, I'm going to push to have it written in Rust. I deserve a little Rust. I have worked hard for it. And I know Donut, so I'm very sure that he has worked really hard for it. But this is what we refer to as off-roading. This is not a supported language. This is probably for something where we are really trying to do something groundbreaking, something new, and we don't really know what sort of security controls are needed yet. And so with that, we can then spend the time with Donut to solve for his particular use case instead of for the vast majority of applications, because we've given secure by default to those who do the sort of more consistent thing. However, letting people steer far too off the road might sometimes be very unsafe and outright insecure. And so initially, we wanted to support everybody's use case. But as with this picture, if Donut had taken the left-hand turn, he might end up with the sharks, and that would not be great. And so we have taken a little bit more of a hands-on approach moving forward, making sure that we're not supporting everything, but most things. And so let's dive into some of our successes and learnings. And so to start with the successes, it really does scale. Time and money that we're spending on meetings, reviews, pen tests, and guidance and recommendations is at a fraction of what it once was. And we are getting really big ecosystem-wide wins. We get eliminations of entire classes of vulnerabilities through stuff like component libraries, which is awesome. We are seeing minimal developer friction. Engineers develop and push code with minimal intervention from the security team, and they do actually look for us for guidance. They come to us. They're not seeking us out for somebody who says no, which is great. We also see improved consistency in essential points like observability and logging and things where we do incident response. And so I wanted to call out 2 success stories. First, when I think about scale, first I think about the sort of manual reviews and assessment work we do in application security, but I also think of the stuff that happens after, the stuff that Ashley needs to deal with for us, vulnerability management and incident response. And so what better example to provide than everybody's favorite Log4Shell, or CV 2021 44228. For those of you who were not there for it, I commend you, and I'm a little jealous that you didn't have to experience this wonderful vulnerability. But for those who also might just need a refresher, Log4Shell was a vulnerability, or is a vulnerability, in a very popular logging library for Java. And it had severe impact across most of our industry and the ecosystem. It was very easy to exploit, which made it incredibly severe. And I would like to talk a little bit about how managed delivery helped us manage Log4Shell at Netflix. And so managed delivery, again, is this sort of, it works with declarative infrastructure and declarative delivery. So it offers automated and asynchronous patching for everybody's instances. Once we were able to identify vulnerable applications across our ecosystem, we could simply automate patching for all of them. And that was across hundreds of applications. We could just rebake, redeploy, and get them patched really quickly. This allowed us to patch instances in minutes as opposed to days. And remember, we run 7,000 plus internally developed applications at Netflix. This would have taken us weeks, if not months, to do without automation. And Netflix engineering managed to remediate 95% of apps twice in 7 days, for those of you who remember that we had to do it twice. So an unintended consequence of this too was this became a great selling point for the managed delivery team, right? To get more people onboarded to their paid pad tooling for developer productivity, since we had such a good use case for incident response. So that was really awesome. A second success story, a little bit more on the sort of scale and ecosystem-wide wins here, focusing on our Hollywood ecosystem. And so when we built out our Hollywood studios, we started building out a larger portfolio of internet-facing applications. So a lot of people who work in Hollywood, they work with dubbing, subtitles, VFX, and they're not necessarily hired by Netflix, like as full-time employees, more like a customer-facing, working within our ecosystem. And so we needed to streamline security processes so that we could get those applications built and deployed to the internet faster. But we also wanted to raise the overall security of those applications such that the accumulated risk of that portfolio did not outgrow its value. And the solution to that was API Wall, or Wally, not to be confused with the robot. I did speak a little bit about Wally in a previous slide. It offers a broad range of security faults, including TLS certs, authentication, security headers, request loggings, rate limiting, PAF, DDoS protection, and a couple of other security controls. It is a filter-based approach that built on top of our cloud gateway, or Zool, the Netflix front door. And what's really cool about this is that whenever we find consistent needs across these applications, we just roll them out as filters, and you get the security controls across all of those applications that are internet facing. It's also great because when we have developers in our studio ecosystem, they can go from get init to a production ready, fully authenticated internet accessible application in less than 10 minutes with no interference from our security team, which is really nice. And so those were some successes, but I would like to not focus too much on those because we have a lot of learnings. As you might imagine with this approach, it gave a lot of opportunity for developers to make their own decisions. But the first thing that happened was that we started building a lot of products. We were like, we're going to build a security product for this, and for this, and for this thing. And we built, and in many cases, they were not really great market fit. Because we had, as security teams, thought that we know security best, we're the security SME, this thing is going to do the thing that we want it to do, and developers will use it, right? Wrong. We built a lot of things that were almost right, and they didn't land as well with developers as we wanted. And so we spent a lot of time then trying to sort of refit, redesign, get things to work, and that lost a lot of credibility between the security team and our developers. It also made us go down solution first, problem second, so we didn't engage with our engineering teams as much as we should have in really understanding the problem that we were trying to solve. And we spent a lot of costly iterations and cycles developing products that weren't, really used, and we didn't focus enough on the user experience. We also realized that being a security enabler sometimes means telling people what to do. And so we had this really hands-off, we are not going to tell engineers how to do security, and that turned into a lot of sort of anxiety with our developers because there was not enough clarity in what we needed them to do from a security perspective. So we effectively took a two hands-off approach in our perspective on security. So it's really, really important that you work together with your engineering teams and that you help them understand how to better use these tools. And one of the ways this might show up is something that I would refer to as the principle of maximum privilege. So we were really proud that we had brought off-sea coverage across all of our ecosystem, but when we started looking at those access policies, turns out they had seeing every single employee in those access policies, so effectively they're not mitigating any risk by just being present. And so really thinking about how do you measure effectiveness of the controls that you're putting in place is really important. Another question to ask is perhaps how much do we observe mutual TLS versus how much of the traffic is actually encrypted. You might be surprised and saddened by the results. Another thing that we learned is that most people don't want to think about security. Again, we were sort of encouraging developer autonomy by giving them ownership of the security risk. We were like, hey, we'll give you all the data, it's going to be great. Do the security thing, but at the end of the day, that's not their jobs. And so the choice there of making something readily available wasn't necessarily the right one. We should have just done that for them. And people don't really want to think about security or making decisions. They just want them done for them. It's also important to understand that the right context is subjective, and sometimes they don't know enough to make the right decisions. And I'll talk through a few examples of this. So we've done several iterations around released privilege in a variety of parts of our ecosystem at Netflix, and we have moved towards more of a right-sizing approach over time. So the first one here, Repo Man, was an attempt at least privilege for AWS roles, where we analyzed unused access and we provided a big dashboard full of findings for our developers. We said, hey, here's all the unused access that you have. It would be great if you pruned it, take it away. But that required our developers to sit down, look at this dashboard that wasn't really part of their jobs, and make a decision about what to do. And so ultimately, they ended up not using it. It was very useful for us as security engineers, but the developers really didn't want to use it. And so the second iteration, RepoKid, focused a lot on making the data that we use for decisions a lot more clear. So we made more investments in making sure that the decisions were correct, and then we just did it for them. And through that, we got a lot of tangible risk mitigation, as opposed to just asking people to do things they didn't really understand. Fast forward a couple of years, we did the same approach in our G Suite ecosystem. So our corporate security team was looking to right-size access to publicly shared files and such. Thought that because of corporate users, maybe we should give them a little bit more autonomy. We did a bunch of tests. Our product manager worked really hard to figure out what's the right fit here. And first we tried with giving them the advice, and no one wanted to do it. They saw it as an audit or as something where they shouldn't be making this decision, ended up not using it, and so we switched or pivoted into a do-it-for-them approach, which has since been extremely effective. Another learning is that paving roads takes a lot of effort and cross-collaboration is hard. And so we still believe that stacking our bets on our central engineering and infrastructure teams' really big investments is the right path. But you need to augment that with security-driven initiatives that drives for the right security end goals. Because at the end of the day, their jobs are not security, and they will have very different sort of measurements of success than you do. You might also find yourself in alignment health, where it's very cool but too complicated, and you all see this great thing that you want to implement, but it requires the networking, the compute team, the central engineering, and the infrastructure owners to all make changes, and that takes a really long time. And then if a leader, say, leaves or gets replaced or whatever, it gets really hard to then get that work prioritized and executed on. So there is a huge risk in stacking your bets too much on these really big sort of infrastructure initiatives as well. So lastly, in terms of learnings, we need to have shared accountability of security posture with our partner teams. So we do still believe that developers can own the security of their applications, and that is fine, but they will not have the holistic view. They will not see the patterns in between applications. They will not see the systematic stuff that we otherwise know, and we need to work with them in setting shared goals. We can't just punt the ownership of their security posture to those teams. And so I know that there was a lot more opportunities perhaps than successes, and I want to make it really clear that we still believe that the strategy is the right one. We just need to evolve it in a way that makes more sense for our modern ecosystem. The cost or benefit of the paved road leans heavily still on the benefit, but we have to continue to evolve our strategy to make it better. And so based on these learnings, I am going to work through a set of recommendations that we have summarized. And so first, productize your solutions. And what do I mean by this? Explicitly treat your developers as customers. Develop capabilities that provide clear value and an experience that they would choose to use. Make your solution a product. And why? Because of this learning that we had about bad product market fit. I want to make sure that we get good market fit, and that we build the right things, and that those things that will be used, and we want them to mitigate security risk. And so how do you go about doing this? Start by scoping the problem, clearly outline all of the use cases, determining applicability, and ensure that the problem, the customer, and the resolution is well defined. Meet your developers where they are, hitch a ride with your developer experience partners, invest in secure solutions aligned with their roadmap, built into flows and systems that they are already familiar with. And start small and iterate. We often in security wants to solve all problems. Instead, choose one problem to solve and solve that well. Focus on the user experience, and usability is really non-negotiable with this one. It doesn't matter how important or great you think your security tool is, unless it's easy to use and has a clear story around user experience. And gather customer feedback. Build empathy and understanding for your customers. And then measure success. Define clear success metrics that align with tangible risk mitigation. You want to make sure that the products that you're building are actually reducing or managing risk. Also hire product managers. They are great partners to security, very underinvested in the security space. And sometimes you might not have the budget to hire a dedicated PM, but at least find PM resources that your engineers can leverage and to do better product management for the products that they're building. But with all of this, don't forget the risk is your customer too. When you build in the sort of customer-centric approach and you're starting to listening very actively to your end users, it's easy to sometimes forget that you are your own stakeholder here and that risk mitigation is the core goal. I know my slides are not working. There we go. Second, add guardrails. What does this mean? Well, build in a shared accountability model so that your security team and their development partners are equally held accountable to the best security outcome. This means meeting with them, setting shared goals, being their partner in really reducing risk collectively. But also build in continuous assurance and governance. Build in auditing mechanisms that validate the appropriate use of the security control, and do limit optionality and enforce critical security controls where it matters. And we do this because full optionality can be stressful, but also it helps us really focusing on the right things. And how do we do this? Well, we set expectations and define shared goals, define your minimum requirements, what are our expectations of developers, and what are we willing to support them with. Build with assurance in mind, and measure these outcomes. There's a theme here on metrics. Enforce security controls where it really matters. Some things are non-negotiable, and so enforcing critical security controls in sensitive or critical infrastructure is completely reasonable. But then also bootstrap security features where you can. Use linters, secure by default in frameworks or runtimes, code at decision checking, all those kinds of things. Just build in secure by defaults where you can. Third, produce actions over findings. As you heard in some of my examples, providing an opportunity for developers to make decisions is not the right and most scalable way. So instead, make actions for them. And so do secure by defaults. Designed to take action or at a minimum, actionable insights. Don't provide just data and expect it to drive change. Be thoughtful about how you serve context and automate where you can. And so we do this because people don't want to make decisions and they don't want to figure out the security thing unless they work in security. They're there to do their jobs, not ours. And how can we go about doing this? Well, start by investing in automated patching. Do things like automated access right-sizing. I don't remember how many jobs I've been in which it's so hard to get the business owners to decide who should have access to what. And instead, if you can just find the smallest group membership and push that out and then right-size access based on their use, it's a lot more effective than waiting for people to decide exactly which resources their people should have access to. Look for auto-remediation for misconfigurations, because in many cases we can't stop people from making mistakes, but we can at least auto-remediate over time. And then whenever you can, disable insecurity faults in the languages that you are using. And fourth recommendation, and this is a theme, I've talked a lot about measurements, please measure the right things. Measure tangible risk mitigation, user friction, coverage, adoption, and utilization. Don't just look for your control to have been adopted across your ecosystem. Look at whether or not it's being utilized correctly and whether that actually mitigates risks. Because users also will find all the ways that they should not be using the product and do it that way. And it's important to remember that an implemented control mechanism does not mean appropriate use of that control. And we do this by testing actual security posture, use frameworks like MITRE and other capability testing, dedicate time on broad analysis and identify patterns to drive future investment needs, and focus on effective risk mitigation and prioritize your risks. Across this broad ecosystem of applications that we have, not all of them are severe or sensitive. They don't hold PII, they're not exposed to the broader internet. And so with a lot of those sort of lack of sensitivities, we might not want to deal with them the same way that we do all applications. So really tier your systems and prioritize where it has the most security risk impact. And lastly, and this might be my most important note here, don't forget that building security products is a huge endeavor. It has a lot of cost associated with it. Maintenance and operability of central platforms is an incredibly expensive thing to do. And so before you go down this path of building large-scale security products, assess the cost and the benefit that you get from it. And we do, as engineers, tend to be a bit distracted by the shiniest and most exciting engineering challenges instead of going for the thing that solves the problem. And in most cases, we probably shouldn't build the thing ourselves. And so buy or borrow before you build. Perhaps you shouldn't build a thing. Maybe somebody else has done that already. Someone whose core business model is to solve for this problem, as opposed to your security team trying to help secure a business doing something differently. But also aim for maybe the 80-20 rule, right? Like when you're going for a vendor solution or an open source project, don't think that that's going to cover 100% of your use cases. Instead, aim for it to do 75-80%, and then you can build additional middleware on top for your specialized use cases, instead of assuming that the vendor solution is going to do everything for you. But also when you decide to build, plan for KTLO and ongoing maintenance. Make sure that your teams have dedicated time to support the products that they're building. And make sure that they also have time to prioritize user feedback and bug fixes, because the strategy relies entirely on the effectiveness of your products, and if your users don't like them, and or if they're not working correctly, or if you're not fixing those bugs that they're really bothered by, they will stop using them. And so with that, we're getting to the end of the road, and I wanted to leave you with a quote from a colleague of mine explaining the paved road. So, just as travelers have expectations of a literal paved road, engineers have expectations of a figurative one. It goes where it claims to go. It's easy to travel on and reasonably direct. Damage to the road is identified clearly and repaired promptly. Maps describe the road accurately. The road itself has good signage telling you where you are, what's nearby, how far it is to certain destinations, and when to turn to reach them. And the road it follows doesn't change often, and only for good reason. And if you have trouble along the way, getting help will be easier than trek into the wilderness. And so with that, a few takeaways. Paving roads for security remains a successful approach to scalable and sustainable developer-centric security for us. We should continue to always, you might also have learned that we have really strong feelings in Sweden about really old intersections. And you should remember to productize your solutions, add guardrails, and share accountability, produce actions over findings, measure the right things, and not forget maintenance. And so that's it. Okay. We can, if anyone wants to ask questions, I can be over here.
Access right side. I get what you're getting at. Could you dive in a little bit deeper there? Because, okay, we got all these access privileges. It's a bit of a mess. I get what you're saying. People don't want to make the decision. They don't want to be accountable. Okay, so what do you do? Do you just break it to see who screens? Obviously not, but what did you do?
There is a little bit of that. There is a little bit of breaking it and see who becomes a little bit noisy about it.
This is why I don't work in ops anymore, because that was my philosophy.
I think my recommendation is, again, to really find the smallest group membership, right? Look at your user population. What are some of the attributes that are true across certain big groups of usage? And so you're really over-permissioning them to begin with. But you start there, and then you start right-sizing based on what they're actually leveraging it. So you're essentially creating your role or your attribute map based on what they're actually leveraging with the context that you have.
So you're able to get like access metadata, for lack of a better word, to say, oh, well, look, they've got these 15 privileges, they're really only using these 3.
Sure,
so
and
that some of those.
Exactly, but that will look very differently depending on which control plane you're talking about.
Yeah.
And so in some cases you won't be able to get that metadata, but then you can be a little bit more, offer a little bit more leeway when it comes to the group definitions.
Okay, thank you.
No more questions? I can answer questions here, if anybody has a question. You can come over here.
That's fine. It's all good. Developers will own their own security posture, and that will be fine. Scares the crap out of many people.
Yes.
And I know you have a lot of controls there, but in your experience, is there one thing that seems to be critical to make that work?
I guess the ease of use of the default security controls, and that will vary depending on what your ecosystem looks like. Right? I think for us, strong authentication has been really effective in terms of mitigating the bigger part of those risks, depending on if you're looking at externally facing applications or internally facing applications. Similarly, segment differently critical applications has been very effective. But it depends, I think, is the answer to that question.
When you talked earlier, you were talking about how you wanted to create an environment where they feel comfortable with coming to you, but in the event that somebody takes a sharp left, what's your discovery mechanism for identifying those individuals and getting them back on track?
It's a good question. Part of that is reliant on having established that relationship already. So they do oftentimes come with us and say, hey, we're doing this thing, and it's going to be a little bit experimental, but bear with us. But now that we're a lot bigger organization than when we started this, it is harder. And so we do have security partners that work with different business verticals to be ingrained in their context, such that when they start making security risky decisions, we have someone on the ground who can then tie that back into the right team and connect the dots.